Hello everybody and welcome back. So I have a very basic fire sim here. Let's hit play and make sure we're playing in real time. Okay, so I'm gonna go up and I have the fire import here, and what I need is I need the velocity, I need the density, and that's it, or the flame, and that's it. Actually we only need velocity, so let's take a look here. And I'm gonna create a blast node and add name equal flame, and I'm gonna scatter points on the first frame. Just use that field to scatter points. And I'm gonna use a time shift, make sure to lock this in so it doesn't change. Okay, and then I'm gonna create a pop network, and on the second input I'm going to isolate everything that's named vel. So we have the velocity field. I'm gonna plug that in the second input, and let's dive inside. And for the source we're gonna use all points, and if we hit play we should see points falling with gravity. And let's make sure we don't have any attributes, so let's add a gravity node. Hit play, we get that. Great. And I don't need gravity for now. I wanted to make sure that we're getting particles. We're going to use pop effect by volume, and the volume is coming from the second input. I'm going to leave everything as the default, and if we hit play the particles are going to be moving and follow, or they're going to get affected by the flow, by the velocity field. So let's add the gravity back, and let's change this from update force to update velocity and set it to 0.5. So now it's 50%, and the other 50% is a gravity. So let's delete that, and let's hit play, and now everything is following the movement in a nice way. Now sometimes they're gonna get the particles are going to be left outside because they don't have field to work with it, and in that case we need to we have to have another force inside that makes sure it moves them. So let's add some velocity at the first frame, so something pointing upward and with some randomization. And I'm also going to add a pop force. I'm gonna add a turbulent a noise, and this is going to make sure that the particles are moving. Okay, let's lower this to 0.5, and let's lower the birth or the life expectancy of the particles. We'll give them a life expectancy of 0.5 and then a life variance of 0.5. So if we hit play, they won't live for too long, and that's what we want. Great. So that's the main idea. Now, if we want to replace this, if we can store this, okay, there's no other way for us to get that data, because the density field is a float. It's a scalar field. It won't describe direction, okay? And then we have temperature, which is again a scalar field. It cannot describe the movements of the voxels over time. But my idea is this: what if we can get, instead of a volume field, a velocity field, what if we scatter a lot of points onto this flame? So let me copy this. What if we scatter a lot of points, something like that. Let's turn off relaxation, maybe more, change this to pixels. Yeah, what if we scatter a lot of points on the field that we're interested in, and instead of caching the velocity, we do an attribute transfer. So attribute from volume, and I want to transfer velocity, and the field name is vel. I'm not sure if that's going to work. Yeah, so let's convert it into VDB. VDB convert into VDB, and then assemble vector merge. Sorry, I'll explain this. So what we did is we converted this into VDB and then vector merge to convert it into a one field. And now if I preview the velocity field, we have points that has the information that we need. Okay, and it's going to be much lighter. 100,000 points is much lighter than a high-res sim. And what if we, okay, now we have this data. What if we can get our particle sim at the beginning to check against this data and find the nearest point close to the source, close to that emission point, and query the velocity of that point. So we have these points here, and let's say this is our velocity field. I'm gonna get, let's put down a color node. So this is the source, and this is the points that have the velocity attribute. What if I can get these points to look up the nearest point and query their velocity attribute? Okay, if we can do that, then maybe we can use that force to advect them over time. So that's great. We can do this in the first frame, actually. So let's do an attribute transfer from this into this. I'm gonna call this, I only want to transfer V. Sorry, like that. So now you see these points, they have a velocity attribute. I'm gonna copy this. I'm gonna connect it here. And if we dive inside, I'm gonna turn off this advect by volume and the pop force. And I'm gonna hit play. So the points, they have an attribute, they have a velocity that they are inheriting from the sim. But the problem with this is we are doing it we're not doing it every frame. So as the sim moves, what we need is, let's say we took the points out of the first frame, we queried the nearest points, we queried the nearest velocity attributes, we used that force to move them. The next frame, they need to do a lookup again and check what is available next to them to use to move along the field. And so the point lookup cannot be done with an attribute transfer. It needs to be done inside the sim. So every frame we move them, we use that new position and do a lookup on this data. Okay, but how do we get this data? Well, we have to do it in the sim. Okay, so when we create the DOP network, we need to provide and do this one time because we don't want to cache the velocity. So this has to happen inside the DOP network. Okay, so that's what we're going to be looking at in the next video, and then once we have the data, we'll start implementing the POP network. But the main idea is, instead of using a velocity field, we're going to scatter a bunch of points where we want to in the field that we're interested in this case the flame or density or whatever, and then we attribute transfer the information, the data from the velocity field onto the points. Okay, so we're basically going to cache the velocity field as points, okay, which is going to save a huge amount of disk space, and then we're going to use it to advect the points. So we'll do that. We'll do the DOP network in the next video and then continue implementing this. Thank you guys for watching, and see you in a bit.